Hi, I'm Mark from Canonical. I'm also on the OSM TSC, and I'm going to be expanding upon this little session that Gilsum did with a little bit more details about instantiation and operation. And I'm specifically going to be talking about scenarios that are going to be part of the Hackfest challenges coming up. So I'm going to be talking about, using the OSM client because we've got a Hackfest challenge about the OSM client. And so we'll do a little bit of explanation of that and try and prepare you a little bit more mentally for once we start presenting the challenges, you'll have a little bit more background and sort of an idea of what things are there. So, first thing we're going to talk about is network service instantiation. Okay, so you remember what Gilsum had up there? You've got this sort of overall umbrella called a network service. And that is what describes things to the outside world, right? That's your external connection point, your external visibility. Inside of that, you have what we call the VNF, which is sort of where the actual software lives. So a network service by itself doesn't have software in it. The VNF is what describes the software. And so we've kind of got these layers that we're going to need to go through. In GitLab down here under osm.etsy.org/GitLab, we have a project called VNF Onboarding, and within that we have a repository called OSM Packages. And this is where we draw all our examples from. We use these packages daily for running sanity tests against OSM as part of the CI/CD pipeline. So chances are, if you're wondering, how can I do this? If you take a look through these packages, you might actually find an example of it. So this is a really handy place to go perusing through. So what do we have here? We've got a basic network function. So we're starting with the VNF. Remember, this now is going to become an actual piece of software that's running somewhere in the world. So the first thing that we're describing is what we call our external connection point and our management connection point. So if you want to be able to talk to this VNF, maybe even that's its external REST API or netconf API or whatever it is that this thing does. You want to be able to expose that on some sort of management network so that you can talk to your function and do whatever you need to on that. We also, in here, describe our VDU. Deployment unit is what represents the actual real running software. So if I'm going to deploy something in Kubernetes, that would be a deployment unit. If I'm launching a VM in OpenStack or in Google Cloud or wherever, each individual VM is a deployment unit. Why are there two levels for network functions? The VDUs work together to form the end-to-end function. So say, for example, I have a firewall deep packet inspector. Those are actually two separate VMs, but for the purpose of my network service, I'm going to treat them as a unit. So I would describe the two VDUs, the packet inspector and the firewall. I would connect their networks up to each other so that data has to flow through both of them. And then I can expose that as, here is my function. So the specifications are kind of like layers upon layers, and they can be difficult to go through, but it's deliberately done in terms of abstraction and layers of indirection so that it can be as configurable as possible. So what we're saying is this VNF descriptor is going to have an external connection so that we can talk to it. There's going to be one VM, and this is the ID that I use later on in my descriptor to describe what this VM looks like, which is like so. Here we've got information such as it's going to boot from glance, for those of you that know OpenStack, if this were OpenStack, you already have to have your images loaded in OpenStack. So you've got something like, oh, okay, Ubuntu, or an image that was sent to me by Juniper for their Juniper network appliance, right? So it could be proprietary software, it could be just a base operating system, it could be, package software, like maybe you've installed some software and you save that as an image in glance and you say, okay, I want to reuse that one. But basically, we tell it, what are we going to boot? So this is day 0. We also say, okay, it's a VM. So it's going to need to have a network card. And we can specify what type of network card, para-virtualized or, anyway, sorry, I can't remember off the top of my head, but there are different parameters that you can do for that. This particular one says, well, it's going to be para-virtualized network card, which means that it is going to do at the hypervisor layer NAT or some other form of translation to be able to manage the data going in and out of the VM. We also are labeling this network card. So this is where that little piece of tying it together from the VDU to the VNF so that the NS can expose it is done here. This is where we say there will be a physical interface, and I'm going to call it this, so when I refer to it in my descriptors, you know how to map it. So the next thing we do is we describe the CPU allocation for the VM. So inside of here, you saw when Gilsum's example where she showed, NS package create, number CPUs is 1. Essentially what that command would do is it would create a template like this here and say, oh, there's your CPU, here's your memory, etc. It'll just create the template for you. So we describe the number of CPUs that it has, the memory, and the storage. We now have everything that we need in order to be able to connect or actually launch this VM. Well, almost everything. The one thing you'll notice is all I did is I described a network, but I never said what network to attach it to. That comes later. Network service itself, again, comes from the GitHub repository if you want to look at this in detail, but I think this is pretty much the entire descriptor for the network service. So it says that we are going to have a VNF, and that is the ID that we want to use. So from an OSM perspective, if there is no package inside the VNF catalog with this ID, then OSM's information model says, hey, you're trying to build something that I don't know about. I'm going to stop you right there. So later on, if you're ever loading packages, you'll notice you always have to load the VNF descriptor first, because the network service is like a table of contents of all the different VNFs that are in it. So network services always sit on top of VNFs. It also has the networking information that we are going to use. So here is where inside this package we said there was one of these, which was right here at the VM level. Now what we're going to want to do is we actually want to describe this in terms of the network service. So the VNF, sure, it's got an IP address and it's got a port and you can reach it on there. But the question is, does the network service need to expose it? Is this something that should be made publicly available, or is it internal? So here's where we describe the fact that, well, we're going to call it management net. I could give this any name. But that is, the handle or the identifier that I give it, saying, okay, this is going to be connected to something called management net. And lastly, oh yes, it plumbs those together so that it knows, when somebody wants to ask about the connectivity, it knows how to respond to you with that. So here we are in our Hackfest environment. You're going to get a VM with OSM already installed in it. here we are coming through this OSM Hackfest Wi-Fi, and it drops us right onto this network inside of the Etsy infrastructure that we call OSM Next. This is a pool, I think it's a /23, so 512 IP addresses available on it. And when we run our daily CI/CD jobs, it'll launch a VM on this network inside of the OpenStack that's available for everyone. And, it does some tests and installs OSM and all that good sort of stuff. So you're coming into the exact same environment that you would if you were an Etsy member and had an Etsy online account access. So just by simply joining the Wi-Fi, we're immediately on the Hive, which is Hub for Interoperability and Validation at Etsy. We love our acronyms in case you didn't notice. So yeah, the Hive is a fairly large network, actually. OSM is just part of that. So we've got a couple subnets in Hive, but if you've ever heard of anything like the Etsy plug tests, where there's interoperability, I wouldn't call them challenges, interoperability sessions going on and whatnot, that takes place over this same Hive network as well. Different subnets, firewalls in between, but basically that's what that's all about. So let's trim things down a little. You're going to receive a VM. OSM will be installed in this VM already, and it will be attached to the OSM external network. So we're going to give you an IP address. You'll be able to, SSH as Ubuntu Hackfest, I think is the password. We made it an easy password anyways. And remember I said there's an OpenStack instance? Well, not only will you be having a VM inside of OpenStack, but OpenStack itself, the controller for OpenStack, is available at this IP address, and you're going to get credentials for that. And you're going to be able to log into OpenStack and see your view of OpenStack, where you can create your own VMs. Or, more probably, you will tell OSM, when I want you to launch a network service, launch it under my tenant. So that way you're not going to interfere with each other. All right, what does network service creation look like? This is your OSM client, OSM. That's a set of Python shell scripts that talk HTTP to the northbound interface. So what we're going to say is we want to create a network service. The network service name itself will be vertical scale NS. So when I go an OSM network service list, I should see one with an ID of vertical scale NS. The network service descriptor that we want to use is this. So I would have had to have loaded an NSD and, of course, a VNFD that NSD references in order to use this. If I didn't load this package, OSM will come back and say, I don't know what you're talking about. What do we have here? So the way it works is when we do this NS create, the OSM instance will launch the VM, launch the VM over here in OpenStack with the parameters that we talked about earlier from the VNFD, and as well, it is going to use this SSH key. So when the VM gets created, it's going to tell OpenStack, as part of the configuration of this VM, please give it my public key so that when it's up, I can SSH directly to it using my private key. Okay, the NBI and the OSM client. So the NBI is an HTTP port. Depending upon how the Kubernetes was set up, it either might be a direct node port, which means that you're going to go to port 9999 of the Kubernetes cluster, and you're going to be talking to the NBI directly. Or because this is Kubernetes and you can set up ingress controllers and do all that fun sort of stuff, you could have the services hidden behind an ingress controller, which uses something like virtual host names to decide what service to dispatch to. So depending upon how your Kubernetes was configured, you might be going to port 9999, or you might be going to port 443. Which is the SSL port of the ingress controller in Kubernetes. Okay, so first thing that happens is we've got OSM client and the northbound interface. So the OSM client will issue an HTTP post request to the northbound interface. This is a post to admin v1 tokens. So here's where we give our credentials, and if the NBI likes our credentials, it will return with a 200 OK and the token that we can use. Now this token has got, I can't remember what the lifespan of it is, like 5 minutes or something like that. So obviously, because this is OSM command, is a shell Python script basically. It's a process that starts up, it'll get the token, use it as many times as it can, and then when this program exits, that token is forgotten about. So every time you invoke the OSM client, it is going to start with this. It will ask for a token for the login. So, oops, 2 slashes here. This should only be 1 slash. But in this particular command, it's vim list. Well, it turns out that the API endpoint for finding all of our virtual infrastructure management accounts is literally admin v1 vim accounts. So if I give my token as part of the headers in this HTTP GET request, it should then turn around and give me a JSON payload which represents all of the VIMs, virtual infrastructure managers, that were present. So OSM client does accept things like OSM-V or -VV or -VVD, which means dump all sorts of good stuff on the command line. So if it's just 1 V, you should see these things going. You should see what URLs you're hitting. If you do 2, you're going to see the data coming back as well. And I think the third one does like connection level tracing or something like that, which I never use the triple V. I've only ever used single and double. So we do have, and ultimately the OSM client takes this and returns us with a nice little table, does a pretty print of it. So we have some OSM client challenges, which basically say, oh, okay, you know, we're getting all this JSON payload, but perhaps it's not a nice output, or perhaps it's missing something. So some of the OSM client challenges will be, you know, take this and make it nicer. And that's why those ones are sort of put in the lower difficulty, because it's not necessarily going to be talking to a network service or OpenStack or things like that. It's just a client server request and response. Helm charts. It's the next thing. There is a particular challenge from Pedro Escalera about the use of Helm charts. So I'll explain the way OSM uses Helm right now. So you've got your request that's going to come in through the northbound interface. That's an HTTP post. It's got its authorization header, everything like that. It's then going to take that request and make a VNF resource record for it, which basically is going to have all the information about the final deployed VNF. Puts a message on the Kafka bus, LCM wakes up, and it says, okay, the first thing that I need to do is I need to figure out where is this coming from. So it gets the package descriptor, the KNF descriptor, it looks it up and it says, oh, there we go. This is going to be a Helm chart, and I'm going to deploy a Helm chart called stable OpenLDAP. ultimately, this translates to a Helm CLI command. Why Helm CLI? Because there is no real library for Helm that we can include in Python. Helm is a command line client that we have to shell out to. And it literally does a, Helm 3 install stable open LDAP, and we give it a unique name, so that way you can deploy a network service over and over again and not collide on that. Now what you'll notice here is that's OSM creating a shell script and executing it. If anyone's looked at security, you know that executing shell commands is a possible avenue for attacking. So Pedro will show us a nice little creative way that you can do some sort of command injection in OSM and cause it to execute arbitrary commands. I personally think that's a really interesting challenge, but you actually have to deploy a network service to get this one going. All right. Gilsum had also mentioned day one actions. We have our day zero, which is, okay, what hypervisor am I going to use? Is it Google? Is it OpenStack? Is it Kubernetes? What image am I booting? Is it a Helm chart? Is it a Juju bundle? Is it a VM? What network is it going to go on? All of those are day zero things. You need to know these things before you can start installing software. Then comes the day one, where the VM has been launched, but we need to log into it and tell it, oh, here's an IP address of something you need to listen to, or maybe I need to do other last mile configuration, like tell it, oh, this is the network interface you should bind to, or something like that. So that's what day one is all about. Now, how do we execute day one actions? Remember, we've got a VM. That VM image came from Cisco or whoever, and it's locked down. It's not like I can just, go in it and add some stuff to it. No, this is like booting from a CD, right? That thing is read-only, and I've got to manage it from the outside. So when we're doing our initial launch of the service, we've got our NBI that receives the post. We've got the LCM that receives the Kafka message. And it then turns around and talks to the RO and says, oh, this is a VM. I need you to launch me a VM. So RO uses the OpenStack API, calls into OpenStack, and says, create me a VM with my single CPU, my memory, and my disk as I wanted. Oh, and attach it to the OSM X network, which I think I forgot to explain earlier. I'll come back to how we knew to install it on OSM X. I may have it later in the slide. Okay, so our day zero is done. The software is currently running, but I need to do some configuration in here, and it's not configuration that Cisco, Juniper, or whoever gave me that appliance, scripted for me. So the LCM can create what we call an execution environment. This is like launching another VM. This is where you can put your code. So maybe that code is going to SSH into this VM and run some commands. Or maybe it's going to post a netconf to its external API, or whatever the configuration is. We're giving you your own space where you can write your own code closely located to the workload in question, reachable on its management interface. That execution environment could be in LXD, or it could be in Kubernetes. It could be a Juju charm, or it could be a Helm chart. So you kind of have 4 options for execution environments, but that's basically the way it works. Is it boots a VM, and then it deploys your management software to a cloud so that you can talk to your VM ultimately. Day one, that's one day. It'll never happen again, not unless you destroy the network service and deploy it again. So this execution environment is relevant only for that initial config. After that, There's nothing that will ever execute in here again. OSM keeps this around, wasting resources, but we have a challenge that says, what if? What if we deleted this when we were done? Because we're never going to use it again. And so that's one of the challenges that we have coming up. Vertical scaling. So a vertical scale, everybody know what vertical versus horizontal? Yes, no, maybe? Horizontal scale is, oh, I've got one copy of my Apache web server running and it's being overwhelmed. Well, what if I put a load balancer in front and then I start a second copy of it up and now I can get twice as much traffic, or a third copy, or a fourth copy. As long as I got a load balancer in front of them, great. I can keep on going horizontally as much as I want. Vertical scale is another way of being able to get more throughput, but still with just one copy. So say I started my Hackfest basic VM with one CPU, and I realized that it is getting overwhelmed. So I can tell OSM to issue a resize command to OpenStack, which then will gracefully shut the VM down, add another CPU to it, and boot it up again. That's an operation from OpenStack. So OSM doesn't really do much more than tells OpenStack, hey, I want to do a resize. Of course, it monitors it, makes sure that the resize operation is successful and whatnot. But that's basically all it is to it, is that we're going to add more CPUs or remove them, or add memory or remove memory. Interesting thing, you can only make the disk bigger. You can't really shrink a disk under OpenStack, because once the disk is bigger, you could have written data anywhere within that disk, and OpenStack doesn't want to get in the business of finding free blocks, trimming, resizing your disk, and whatnot. So this, you typically aren't going to touch your disk storage unless you're increasing it. All right, so those are, in at a very high level, sort of the challenges that we're going to be doing. And I'm going to go all the way back to this one here. This is what I forgot to mention. Remember I said that I was going to have a network? I called it Management Net. At instantiation time, I am augmenting the network service descriptor. So I'm saying, okay, you've got, in the YAML descriptor, you've got the node basically that says, oh, this is my external connection point, and it's got a name management net. Now what I want to do is I want to add one more thing to that particular node within the YAML. I want to say that Vim network name is going to be OSMX. Now I could have hard-coded this into my descriptor. The reason why we don't typically do that is because we don't know what your network is going to be. We don't know, what the names are out there. So we leave it deliberately blank and expect at instantiation time, please, from an OpenStack perspective, tell us what OpenStack network to use for our external. This sort of thing, I happen to do it for the network name that we're going to attach to. I could have also done it for the CPU count. I can override additional things inside of here, inside of this config at launch time. Not everything can be overridden, but a lot of things can be. And that's how OSM addresses, localization and being able to have sort of generic descriptors that instantiation time you turn into something concrete. All good on the overrides? Because I do believe that's going to be also necessary for the remote code execution. Because we can supply arbitrary things here, I'm not sure if it's that is where we're doing the remote code injection, or if it's even more subtle than that. But yeah. So that is OSM usage and instantiation, specifically for the different things that we might be doing this week as part of the Hackfest.